For our final 2-2 example video, we will be looking at 38, 40, 42, and 44. The first three are matching, but don't dismiss these as simple and I'll just copy the answer out of the back of the book, because if you do, you won't know what you need to know later. So think about these problems in detail, and they still won't take long, but you'll get more out of them if you take them more seriously than the little devil on your shoulder tells you you should. Alright, I mentioned in a previous video that you should, when the exponent is negative, rewrite the function so that you see that this is just a transformation of the parent function 1 over x. And the coefficient is positive, so understanding that this is a transformation of the parent function, which looks something like this, makes this problem a much easier problem to think about. And then when you look at this crazy diagram they gave you to work from, we're only in the first and fourth quadrants, so we don't get to see what the left side is doing. In fact, we don't really have to worry about that, but we have to pick out which one of these curves matches what we expect. Well, since this is a transformation of the parent graph 1 over x, and since our leading coefficient is positive, that means that I am looking for something that looks like what I drew in the upper right corner of your screen here in the first quadrant. So it would have to be, from these choices, it would have to be A. So the answer to 38 is, in fact, A. On 40 and 42, and in fact, if I can grab it quickly enough, I might be able to tell you what page you should look at from your study guide. You did some practicing, playing around with some different exponents and trying to make some conjectures on page 3 of your study guide about rational exponents that should help you here. And if you did not reach this conclusion in your conjecture and you didn't write anything closely resembling what I'm about to say, you should probably flip back and record this on page, what did I just say? Page 3 of your study guide. Alright, so when we look at both of these, 40 and 42, we have rational exponents. And if you did not write this down, if this did not occur to you, this is a very important thing to help you think about these graphs. And that is that when you have a rational exponent, the big number wins. So when I say big number wins, it's kind of like this graph is going to look more like a power function. I'm sorry, this graph, because I was talking about both of them at once. Number 40, because the big number is on top, is going to look more like a polynomial, and I'm going to put that in quotes because there's a lot we've talked about with polynomials, and I don't want you to get sloppy in your thinking. But in other words, it would look more like a square or cubic graph than it would a root graph. So I expect the graph to go up because of the top number in your exponent being bigger. So the big number wins and makes it more like a polynomial. Where in 42, because the big number's in the bottom, this one's going to look more like a root graph. So put that in quotes, because it's not going to look exactly like it, but it would steer the behavior more towards this type of a shape. Alright, but now let's go back and finish number 40, because the other really important thing to notice here is that if I have a negative A, this curve I just drew as an approximation of what the graph should be doing should then be turned upside down. So instead of being in this quadrant as I drew this implying that it would look more like this because of the negative. So for number 40, if I'm looking for that type of a graph, it would be G. So G is my answer to 40. And then on 42, we had a positive leading coefficient, so nothing is going to change the fact that the overall shape should look more like a square root graph. So this one has to be D. And that's the sort of reasoning and logic I would like to see on your paper described, so that anybody that picks up your paper will know how you made your choices. Then we have one last one. And I didn't put a lot on screen here. I'll just read these directions to you. It's kind of wordy directions for this problem. But we'll do the problem as we read through the directions. and the directions say, state the value of the constants k and a for k times x to the a. So obviously for this one, our k is -4, and our a is 2/3. And then we are to describe the portion of the curve that lies in either quadrant 1 or quadrant 4. Because a function won't have something in both quadrants, it's going to have something in one or the other. So for our thinking purposes here, we're only going to need the right side of the coordinate plane. Well, if we have a 2/3 exponent, if you were just thinking about what I said earlier, since the larger number is in the denominator, I'm expecting more of a root shape over a polynomial shape. And so I would expect the graph to look more like a square root graph, all right? But then taking into account the fact that our a is negative, I'm actually not going to have that graph. I'm going to have an upside down section in the denominator. So how, and like I said, we got to stick with the wording. Describe the portion of the graph that lies in quadrant 1 or quadrant 4. So we would say, and I'm okay with this wording, others might not be, but I am, an upside down, try that again, an upside down root graph. And I guess we could go ahead and finish it out right there, in quadrant 4. So we've taken care of that part of the directions, and then the next step is to determine whether this function is even, odd, or neither. So we kind of do this in sort of a bulleted format here. So the next thing to determine whether it's even, odd, or neither, I'm going to plug, but not right quite that large, I'm going to plug -x into the function. So I write f of -x equals, lost my place on the page, -4 times -x to the 2/3. Then I have to decide what's going to happen to the negative that I just stuck inside. Well, since we have a 2 in the top, whatever I put in as my base at some point is going to get squared, which is going to make that negative irrelevant or go away. So that gives me -4x to the 2/3, which is exactly what I started with. So we would say, and I'm okay if you don't make it a complete statement here, just because there's enough to write without this. So we could put comma, f of -x equals -f of x implies odd. I'm sorry, not odd, even. And I just said that wrong too, didn't I? Rewind, trying again. F of -x equals f of x, because it equals what we started with. So our function is even. Well, that becomes really important to our initial analysis that we expected to see this cubic looking graph in the 4th quadrant, because now, having added to our discussion the fact that this is even, I now expect that when I have this piece on the other side, it's going to reflect. Well, as it happens, the remaining part of our directions for this problem tell us to describe the rest of the curve, if any, and then graph it to see if it matches your description. And that last bit, then graph to see if it matches your description, becomes really important, that you only do that after you've done everything we've done here. And we will write the one more step that we just sketched there in orange, and that is the left side of the graph is a reflection in quadrant 3 of the right side. And we don't need to say again that it's in quadrant 4 because we already said that in an earlier part of the direction. And that is the last example of your 2-2 evens.